Hello everyone, and welcome to Office Hours with the Meter Environment team. Today's session will focus on hydrology measurements, and we're shooting for about 30 minutes of Q&A with our experts Leo Rivera and Chris Chambers, whom I will introduce in just a moment. But before we start, one housekeeping item. If you're watching this video and you think of a question you'd like to ask our science experts, we encourage you to submit your question on our website at metergroup.com. And then someone from our science and support team will get back to you with an answer via email. All right, with all of that out of the way, let's get started. Today, our panelists are application specialists Leo Rivera and Chris Chambers. Leo is a research scientist and director of science outreach at Meter Group. He earned his undergraduate degree in agriculture systems management and a master's degree in soil science at Texas A&M University. There, he helped develop an infiltration system for measuring hydraulic conductivity used by the NRCS in Texas. Leo is the force behind application development in meters hydrology instrumentation, including the SATURO, HYPROP, and WP4C. He also works in R&D to explore new instrumentation for water and nutrient movement in soil. Chris Chambers operates as the Environment Support Manager and the Soil Moisture Sensor Product Manager here at Meter Group. He specializes in ecology and plant physiology and has over 12 years of experience helping researchers measure the soil-plant atmosphere continuum. Thanks for joining us, guys.
Yeah.
Thanks, Brad.
Happy to be here.
How you doing, Leo?
I'm good.
It's been a while.
Yes, sir. It has been a while.
All right, let's get started taking some questions. Our first one here, and these first few will be covering the SATURO. This first one is asking, what is the depth range over which a device like the SATURO integrates measurements of hydraulic conductivity?
This is a really relevant question to anyone using the SATURO, really. So just to recap, if you're not that familiar with the SATURO, we've got a 5 or 10 centimeter ring that we drive into the surface of the soil, right?
Yep.
And so it isn't really that straightforward what the depth is
No, it's really not. There's a lot of factors that actually impact what that looks like. The biggest factor, though, is how deep your wetting front goes during your measurement, which really primarily is a factor of how long you run the measurement.
And it's really hard to know how deep that goes.
Yeah, it really is. And it's not really something that you can super easily quantify. But it is something that you will see is if you run measurements long enough and you, for example, have a less permeable layer down a little bit deeper, you could have a measurement where you hit a steady state flux and you're getting a good steady state and calculate hydraulic conductivity. If you let it run long enough, you may see a stair step down in that infiltration rate when you hit that less permeable layer. But the question, of course, is how deep is that? What is that you're actually looking at?
Really, the relevant question here is, what's your soil horizon? What's your soil layers look like?
Yep.
If it's all the same layer, if you don't get down to another layer, then it really isn't as relevant of a question, is it?
Yeah, if you don't know what's going on down there, it's really hard to say much of anything.
You've probably heard this from us before, but dig a soil pit or take a soil core.
Yep.
Learn as much as you can about your soils.
Yeah.
And for something like hydraulic conductivity, particularly learn about the different soil layers that you're going to encounter and what depth they're at.
Yeah. Yeah. But you're the best thing to do is, or the best thing to understand is you're primarily looking at the surface, and in most cases, what's happening within the upper 20 to 30 centimeters, depending on how deep it gets.
Probably. Right?
Yeah. In most cases, probably about 20 centimeters is the deepest you get, because that 5 centimeter insertion ring, you're unless it's a really low permeability soil, then you're probably going to be in the upper 10 centimeters for really low permeability soils.
And so this does kind of lead into another question that we get quite often. What if they want to know about deeper soils?
Ooh, good question. Nice feed, Chambers. Well, there's a couple approaches you could take. One approach that people take is they actually excavate down to the layers that they want to measure at, and then they will place the infiltrometer head at those layers. Of course, that does mean more site disturbance.
The physics are pretty much the same, though, right?
Yep. Yeah. And maybe in the future, because borehole methods are another good way to do that. They have their challenges as well.
Right.
But one thing we'd love to explore in the future is actually being able to do borehole measurements with the SATURO, and that's something that we're looking at. But that's another approach, is a borehole approach. But yeah, again, those have those challenges, their challenges as well. But either way, you have to get down to the layer that you want to measure at. So.
Okay, this next question is asking, how is the field saturated hydraulic conductivity error estimation calculated by the SATURO?
Yeah, so it's a really good question, and we're always happy to share those equations with you as well.
Is it based off of the flux data?
It is based off of the flux data and the variability in the flux data. And what we're doing is looking at, we're actually calculating looking at the how much that flux data varies across a measurement. And then we look at, for both the low and high pressure heads, how much that flux data varies. And really the bigger question is, what is an acceptable error value? And my typical rule of thumb there is, I want the error value that gets spit out from the device to be at least an order of magnitude less than the final hydraulic conductivity value. Yeah. Okay. If your error value is larger than what the actual hydraulic conductivity value is, likely something went wrong with the measurement, and I would recommend repeating it.
Or you might not be at steady state yet.
Yep. So either way, you need to either continue your measurement or repeat your measurement.
That's right.
Yeah. And there are a lot of factors that can contribute to that.
Maybe doing another run, because achieving steady state is an assumption in the SATURO measurement method.
Yeah. It's really important.
And so what are some of the variables that are going to lead to a high error?
Yeah.
Assuming you get to steady state and you're getting some your flux data stabilized, you're getting good depth data. Yeah. What are some of the things that could be causing a high error?
So the things that typically cause error, it's just some of that is just the natural variability in how the water actually infiltrates into the soil. It's not a perfect, I'm infiltrating at the exact constant rate and decreasing. There are things that happen as the water's infiltrating into the soil. You get pores that open up, and you also have air that moves through the soil and releases, and so you get sudden changes because we're measuring at such a high rate, it looks much noisier than what you would expect to see sometimes. Right. So there are some of those things, but also it could be if you have a leak somewhere in the system, that can result in higher error. So always check to make sure there's no leaks around the infiltrometer head, that you don't see water ponding up around the exterior of the device.
Check your gaskets before you install it.
Yeah.
Make sure that those are all aligned. And the nature of the measurement itself, Brad helped us out by calling it out as field saturated hydraulic conductivity. So there's a stochastic element just in how air is trapped in the soil in this measurement, right?
Yep, exactly. Yeah. And we never, for field measurements like this, we never really try to call them KS, or saturated hydraulic conductivity, because most cases the soil's not actually fully saturated. There's always some entrapped air, and there's just things that prevent the soil from fully saturating. So so there are just various things that cause some noise in the measurement, but that's normal. Right. And the main goal is that we just don't have so much noise that we lose trust in our measurement. And that's where that error value is helpful, is it helps tell you if the error value is bigger than what your hydraulic conductivity is. And
if it looks alarmingly large, dig into your SATURO run data and take a look at your flux data.
Yeah.
This question, do the data from the SATURO take into account pressure cracks and cracks in soils?
Cracks in soils.
Yeah. Yeah. Well, unfortunately, this is something I have a lot of experience with. Did a lot of my research in vertisols, which are soils that crack a lot.
Again with the vertisols.
That's because they're the best soil to study.
No, are they?
They're one of the most painful soils to study. But if you like a challenge, study vertisols. And only soil nerds are going to get that. But that's a really good question. It depends on what the cracks look like. One interesting course with vertisols, as you're infiltrating, the cracks are actually going to start to close because that soil starts swelling back up.
Right.
Ideally, we're really not measuring on cracks unless they're permanent cracks in the soil that are always present.
So for saturated, I mean, saturated are the conditions in which cracks should be minimal, right?
Yeah.
And so if you're taking these measurements in August, and let's just, stick with the example of vertisol since we're already there.
Yeah.
Do you want to pre-soak it quite a bit? Like, is a KFS reading even really? Can you achieve that in certain conditions in a soil like that?
And some of those soils, no. And if you're going out during the wrong time of year to make those measurements, you could dump 500 gallons and still not close those cracks up.
And the SATURO might not actually even give you a reading if the cracks are too big.
Exactly.
You won't be able to maintain a 5 centimeter water level without dumping like 200 gallons in, like you said.
Yeah. Yeah. So for those really highly cracking soils, the better thing to do is take the measurements during the wetter part of the year where those cracks are not quite as big.
Now, let's contrast that with, say, macropores, in like a well-structured soil with good soil fauna. Even if you are in the right time of year, where do we draw the line between macropores and cracks?
Yeah, macropores are absolutely important to measure, and that's actually a good distinction to make, because as we talk, let's just talk about soil health. One of the big things that we talk about in terms of soil health is that by doing these practices, we're improving our soil structure and its ability to infiltrate water. And a part of that is improving the macropores, which come from root channels that are decaying root channels, worm holes, other soil fauna that actually helps create those macropores. We want to characterize that. And in most cases, we can characterize the macropores with the SATURO. There are situations, of course, where sometimes the macropores are so big, it's really hard to measure.
Or you've got cicadas burrowing out, leaving tubes for water channels going straight down to it.
Which there's a really cool publication on that, actually. Or even ants, like fire ants, actually leave really large channels in the soil. But there are many examples of where people have actually made those measurements and looked at those impacts of those different creatures on soil hydraulic properties. So I think you can measure those, and you should. Those are the things that we want to actually characterize, because they are more so long-term. They're not something that close up due to swelling of the soil. And those are the things that the management practices that we're trying to understand how they impact the soil and characterize that.
All right, moving on. You've mentioned this just a little bit in passing, but how much does soil type affect the water use and flow rates and all that kind of stuff when working with the SATURO?
Yeah. I mean, soil type has a pretty big impact to some extent, but it's actually more so the strength and structure of the soil that impacts things more than anything else.
And that counts for structureless soils. Where that structure is just absent. And it's just going to be the porosity and the texture that are primarily driving it, right?
Right. Yeah. In structureless soils, it's primarily the texture that is the driving factor, and bulk density, of course. But the thing that we have found in making these measurements is that, yes, texture has an impact, but structure has an even bigger impact on how much those properties can vary. So both, it's all important. I mean, we need to know these things, and we have recommendations, of course, on settings and stuff to use for different soil conditions. It absolutely has an impact, but there are other factors.
Take your soil cores, understand what type of soil you're working in, and set those cores aside in case you need them later, if you don't immediately need them.
Yeah. And one of the things I always encourage when taking these measurements is take other data, other metadata to go along with these measurements. Soil temperature, soil moisture, all those data can be really helpful when trying to do analysis and understand, okay, what are the factors that are actually impacting my soil hydraulic properties?
This next one, do you have any experience measuring KFS at multiple soil horizons? You've mentioned this a little bit. Can you infer KFS at multiple horizons from a single run at the surface if you run it long enough? Or is that a slippery interpretation slope?
So this does become a sampling issue as well. Particularly where you get soil type changes. But this is a little bit interesting because, you get a heterogeneous sample, right? Like a soil horizon. And does the SATURO kind of give you a good overall integrated measurement? Is it just a straightforward sum if the influence from the SATURO is crossing soil horizon boundaries? Can you take that as like one kind of summation at the end, or are the different soil horizons going to throw it off?
Yeah. Well, the one thing I always like to point out is that the thing that's going to impact how fast it infiltrates is whatever is your most limiting layer. So whatever layer has the slowest lowest hydraulic conductivity, slowest permeability, that's going to be the layer that impacts the measurement the most. If that layer is at the surface, as you get deeper down, you're never going to notice the influences from those other horizons down deeper, even if they have a higher hydraulic conductivity, because your surface is your most limiting layer.
That's a great point. It's a resistance in series, so you can look at it just as the sum of each layer of resistance.
Yeah, exactly. Yeah, so this is a tough one, and it is. I like a slippery slope. It's just fun with hydraulic conductivity, but. I would say it is a little bit. If you're really interested in characterizing the horizons themselves, the best thing to do is actually take samples and characterize those layers in the lab. Because then you can really ensure that the only thing that's impacting that measurement is that layer that you sampled from.
And you don't have side channels or,
Yeah. And so that's something where like using the tools like the KSAT in the lab, but that's where there's always a pull between, do I do lab measurements or field measurements?
And both have a niche.
Exactly.
They both give you different information.
Yeah. And so it always just depends on what your goals are and what you're trying to understand. And this is probably one of those examples where I would actually recommend making these measurements in the lab.
And you could even take a core with that and break that core down into the high prop sizes, into the high prop ring sizes. Or KSAT ring sizes, and not have to dig a giant pit.
Yeah, exactly. Yeah. Every measurement has its purpose in place.
Could you elaborate a bit more on differences in KFS for poor and well-structured clay soil? Is poor structured clay soil more common in fields?
This is a good place to kind of use compaction as an example, isn't it? Because compaction has a huge impact on breaking down structure or destroying structure, and you can definitely see it in the KFS. And the SATURO is a great measurement to do that, since you can just crank up the pressure and get a KFS reading in a compacted soil. That might otherwise take you days with another method.
I would say that I wouldn't say that one is more common than the other. It really depends. There's so many factors that influence what structure looks like Chambers said, compaction.
Land use history.
Land use history, chemistry, of course, because soil chemistry makes a big difference on what the structure looks like. And so and of course, that's why with a lot of these things, we're trying to look at management practice and trying to improve these properties. And the thing is we always notice the ones that cause issues. Like, I mean, you have a forestry background, Chambers, and you know the impact that, of course, post-fire impacts, but also the compaction that comes from the logging, from forest management. And those are the things that really, because that becomes the most limiting factor, again, those are the things that cause issues. And that's when we start to see higher rates of runoff, erosion, things like that occur.
And there might be things that you don't see further down, like a clay pan or something that's a barrier to water infiltration. You might be your run might be going along nicely, and if there's a caliche layer or a clay pan a couple of inches down, things might just go off the rails. And if you don't know anything about that, you're going to have a hard time interpreting your data.
That's why I think it's always important to really understand the soils below and what's happening. Even if you're not a soil scientist, I mean, the things that you're studying above ground are impacted by what happens below ground.
Exactly.
What settings do you recommend for a high infiltration or very sandy and disturbed soil? This soil has been conventionally farmed on for many years and is therefore very unstable. I've been playing around with the settings, but I've never seemed to reach pressure fully, and my flux data is therefore quite noisy.
Noisy flux data.
These are always a little bit of a challenge. One of the first things I usually recommend, especially in disturbed or very weak structured soil is using the 10 centimeter insertion ring first, because it just gives you more area to hold things, and also helps slow down that infiltration rate.
Right. Yeah. It gives you a little more control over your sample.
Yeah. And then from there, it's you don't need as big of pressure heads, and you don't need as big of differences in your pressure heads for the dual head method to work. So you can decrease your pressure heads. You can even go down to like 2 and 5, 2 for your low and 5 for your high pressure heads, depending on how bad it is and how high it's infiltrating. Because we're measuring the pressure heads no matter what. Even though technically it's holding a 5 centimeter water level, we can use vacuum to actually decrease that hydrostatic pressure head.
That's really interesting.
Yeah. So
much fun with this instrument.
Yeah. So yeah, you just kind of have to tweak and see where things go, but definitely for soils like that, use the 10 centimeter insertion ring too. That helps a lot.
Okay, here's a fun one. Any recommendations for measuring hydraulic conductivity in peatlands? Can we expect much variation in peat soils?
Oh, that's really interesting.
Yeah.
But the principles behind the SATURO should work in peatlands, no?
For sure. Yeah, the principle should work. I don't have much experience measuring in peaty soils.
Right.
I would expect to actually see really high variability in those, like spatial variability in those soils.
I guess it depends on the cover type above it, and the depth of the peat, and what else would we be looking at there? Yeah,
I assume there's just so much activity happening in those soils because there's a lot of organic matter to break down and
different adsorption to the particles.
Yeah. Definitely. Principles like what we do with the SATURO should absolutely work in settings like this.
The KSAT as well, right?
Yeah.
KSAT should work. Now, what about the high prop with?
This is
soils?
a great scenario for the high prop, because PD soils tend to have really high water holding capacities, and the bulk of that water is held in the range that we're measuring in the high prop. And so you can actually really characterize those samples well and get and measure the unsaturated hydraulic conductivity really well, and then tie that in with your saturated hydraulic conductivity.
Do the Van Geneuchten parameters hold? Does the idea behind that hold for PD soils, or would you use a different model?
I would probably use a different model.
Okay.
And I'll be honest, I'm not a huge fan of the Van Geneuchten equation myself, at least the traditional Van Geneuchten equation. And that has to do with the residual water content parameter that they use in there that we know doesn't actually exist. But PD soils also tend to probably be more bimodal. And so that means you're going to have more of a stair-step curve. There are models that work better for soils like that. Okay. It's a lot more like our soilless medias that we work with. But there for sure are models that work well for that. And the high prop has been a fantastic tool for those types of soils.
Nice.
All right. Here is a recommendation from one of our listeners. Regarding extrapolating the flux curve to estimate steady state, I would recommend that you use a stretched exponential curve fit. The stretched exponential provides a better fit to the early rapid decline and a better approximation of the plateau representing a steady state.
Yeah, so I know where this is coming from. This was in one of the past webinars. We talked about some approaches that we've been testing where you can actually you take just some of the early data and then extrapolate your steady state. And so that's a way to make faster measurements if your limit's strapped for time. And this is actually a really good recommendation, and something that I plan to play with in some of those data at some point. But it is, John Norman actually spent quite a bit of time doing this, because we actually got we worked with John Norman on the principles of the dual head method. He did a lot of that in his research. And what he did is he did this exact thing where he actually extrapolated to steady state.
Okay.
So this is a really good recommendation, something that we will play with more, but it's not something that is done in the SATURO itself right now.
Now, expand on that a little bit. Tell me about the stretched exponential curve. Like, an exponential curve is pretty easy to wrap your head around, right?
Yeah.
How's the stretched different?
Yeah, I'd have to actually look at the math a little bit. I don't know exactly how it differs, but I think from and we've done some stuff where we're actually trying to estimate time constants and stuff like that from data, and it's very similar. And the problem with the exponential curve is it sometimes actually goes for too long, and it doesn't actually match what you see with field data. When you reach steady state, it does it flattens out quicker than what your exponential curve actually shows. So it's a method that might work better for taking a short period of data and trying to estimate your steady state.
Interesting.
Okay, so we're close to the end of our time, so this will be our last question here. And they're asking, how can one take care of climate change impacts on the models to ensure efficiency in our research?
As far as saturated hydraulic conductivity goes, let's stick with that. The actual physics of water moving through the soil aren't going to change with climate change, right? But the variables that affect it are the things that we're going to want to study, right? Yeah. And so this is where I think something like the SATURO, hydraulic conductivity in general, and also field measurements of hydraulic conductivity are really going to help us how the things that climate change affects are going to have an effect on the soil.
Yeah.
Not just the soil, growing environments in general.
Yeah.
So I think the SATURO is going to be an important tool to help study those effects and not so much worry about how climate change is going to affect that measurement principle.
Yeah, no, I think a really cool project that has kind of looked at some of this stuff is the Torino project, where they have all these lysimeter stations in Germany, and they're taking these large monoliths from different climatic regions and then moving them towards other climates that match what they're predicting those regions to experience.
That's cool.
Due
is
to
that
climate
still
change.
going?
It is still ongoing.
Wow, that's like a 15-year project now.
Yeah, it's a long-term ongoing project, and it's really cool because they're looking at how climate change is going to impact a lot of these soil properties.
Yeah.
I don't know if they're measuring some of the hydraulic properties of the soil, but that would be some cool work to really be able to do it and look at those things. Yeah. But yeah, there's a lot that needs to be understood about how climate change is going to impact a lot of these variables, and using some of these tools and some of those approaches is I think is really neat.
And the soil health approach in general is going to be a helpful way to organize and approach that research.
Yeah. And I mean, one of the biggest things we know is areas are becoming more droughty, and especially in critical areas where we need to grow things. And so using tools like this to understand how we can increase our ability to infiltrate, but also increase the ability to retain water
and what
in
the
soil.
long-term effect on the soil health is going to be with these changes.
Yep. So,
All right, that's going to wrap it up for us. Thank you again for joining us today. We hope that you enjoyed this discussion. And again, if you have any questions we didn't answer, please contact us via our website, metergroup.com. Finally, you can subscribe to the Meter Group YouTube channel and accept notifications to see previous episodes of Office Hours and to get notified when future videos are available. Thanks again, stay safe, and have a great day.